All right, goal here is one try project review, end of quarter, spring 2018. This is Garrett Hedman. We'll see what we can get here. I'm going to start off by saying that starting a project is never easy. Lots of groundwork, theoretical work, motivational work that needs to be laid to come off successfully. This is third quarter in a row where that I had to think about this, and I had to know what I was going into. But with the right strategies, I feel like I really pulled this quarter off. And, a lot of these presentations, you're going to see the goals that you're trying to reach in research design and technology goals. But for me, it was what questions are we asking and how well are we asking them? All the goals were question motivated. So I'm going to kind of take you through this process, see how we laid that foundational work, and see how we can, where we're at now. That's me. I'm a lion with stilts. Or maybe I'm this grass. Either way. So the first thing that we did is we had to have an approach. And I thought our approach was very good at trying to figure out what problem will work. Because we started figuring out, well, what if we're, instead of looking at problems we want to solve, we're looking at characteristics, seeing what behaviors those cause, and seeing what kind of behaviors are interesting and what kind of behaviors do we want to see. So it's not so much starting with a problem, but starting with something that we want to see, which will eventually lead to a problem of, oh, we're not seeing this behavior, and then we'll ask, why aren't we seeing this behavior, and then we'll start coming up with some design solutions. And that's kind of tricky, that's a little weird. And we did this because one, Josh and Armand's project was really pushing us this way, but for me, I was really starting to look at how the design of these 3 different banana models I was creating was creating really, really different experiences. So we were looking at the banana knowledge to help. The one thing that we were looking at particularly, or I was looking at particularly, is how knowledge on a banana plantation helped people respond to specific problems, whether fungus was infesting or pesticide or pests were coming on the crops. These different cues had them respond different ways, and so they built this relationship, this causal relationship, that a specific piece of knowledge will help me address a specific problem at a specific time. And they kind of built out these conceptual understanding of what a farmer would need to do to resolve threats to the plantation. And we kind of use that as a platform to start understanding, threats. Start understanding just questions that we might be interested in. But again, like I said, it wasn't necessarily goals, but questions that guided us, because then I had to ask, but what's the bigger conceptual question? What is this getting at? And that's where I started doing elevator pitches and just started saying, like, what do you think about this? What do you think about this? Trying to narrow this idea of a bigger conceptual question. I knew I started wanting to apply to stoichiometry and chemistry, but knew there was a little bit to think about. So yeah, what was the bigger question? Once I figured out what the bigger question was, and that was really looking at how people use knowledge to solve new problems, we needed to see, what does this knowledge look like in a specific context? And even if it was chemistry, exactly how would I know if they're solving new problems? What would it look like? What kind of questions would they be able to answer? And that's where I had to do a deep dive into what is the knowledge that people use for stoichiometry, and what knowledge do they not have or do they have to solve these new problems? And so that was the next questions that I had to look at. And so we did a deep dive, a deep analysis of building out entire knowledge maps of all the stoichiometry content, and seeing where the breakdown was and what kind of missing information there was. So after we did a deep dive in, kind of noticed that there was these conceptual problems that people were having. There was this idea that people didn't understand the algorithm as much, that they were focusing their knowledge on different parts of stoichiometry. We had to ask, well, how can we solve this? What are the methods and approaches that might help us build this procedural understanding, that is, that this conceptual understanding of how to use the picket fence in stoichiometry problems, the conceptual understanding of what is a gram, what is a mole, what does that look like, the conceptual understanding of you pulling numbers from periodic tables and chemical equations and turning them into ratios that can then be converted into something else. Like, these are complex ideas in terms of not your ordinary ideas, and they can be used with each other in different ways, and they can be used to solve different problems. So how can we get people to solve this? And that's where I started prototyping some ideas, building out some design arguments, and kind of coming up with this idea that maybe the answer is kind of take a puzzle approach. That maybe you give the solution, but they have to figure out how you can kind of arrange these ratios in ways that can help them solve a solution. And they'll have to understand, at what point do I use knowledge so I can get further to my solution? And how does using ratios change my overall conversion? I realized examples in this would be much better than a picture of minions, but I'm going to keep going. Do we know that this is the perfect method? No. Why? Well, because we don't have all the information about puzzle game mechanics and what behaviors they'll cause. I did run a couple prototypes and did see like some pretty good responses in terms of picking up how to get knowledge and how to use knowledge and how to solve new problems. So the system worked, but I don't have excellent data for it, and I don't have the theory backing it up, which will lead us to what we're leaving off on. But I do want to continue on what we did this quarter, and that is I did take a little hiatus and start working on a JS boot camp and thinking about how to teach it. And at this point was actually my Delta Lab presentation, so I had to take all that information that I had started to gather and kind of put it in a narrative form so people can somewhat make sense of what I'm thinking about and give me the feedback that I would need to continue my work. And I thought I did really well with that, mainly because we got great article recommendations. People understood the problem. People understood the conceptual contribution, this idea of solving new problems with existing knowledge, and the problems that existed with it currently. So nailed it. But that was also 2 weeks out before finals, so we did have a little bit more time, which let me play around with this what next. And that is that, well, this is actually a problem part of a class of problems of a little bit of transfer learning, a little bit of intelligent tutoring systems, a little bit of constructionisms, and that's what I really need to think about now is kind of what is this conceptual backing of this project, what is the class of problems it's going to contribute to, what are the approaches that are currently in those problems, and that's going to take a lot of work. So I'm really excited. I'm hoping you see these now. In the past 2 days, I've been able to map out a map to a conceptual approach. I took all of Matt's articles and kind of like pieced them together and said, what is he trying to say with these? And really what Matt ended up giving us is kind of giving us an introduction to the theoretical forms of our paper, or of our understanding of the project. If you look at this map, you'll see. Okay, I'll try and do this. Yes, you'll see that what we'll be focusing is on, like, well, what are we trying to teach? How are they going to be invested, and how can we help them get invested? So little mechanisms there, some approaches that other people have taken on this, and just kind of some bigger theories that kind of tie these three things together. Still very rough drafty, but I was pretty excited to come up with that. And I realized as I was reading and answering these questions, I do need to come up with some sort of higher level, how can I start thinking about these things at a deeper level? So I actually came up with a design argument of how I should read better. This was all in the past 2 days, spent like 8 hours on this, not that much time. But what was really exciting is that this is the beginning of summer, where I'll have plenty of 8 hours days. And, usually it was a week to put in these 8 hours, but now that I can dedicate more time to it, making maps, making reading arguments, thinking critically, like what do I want to see by the end of the 8 hours? What do I want to create? I think it's just we're going to explode in terms of how quick we'll be able to move through things. So yeah, very good quarter in terms of pushing this narrative, pushing this story. Super excited about the summer. See what kind of things can come out of it. We definitely have a direction. Definitely have a promising start. Lots of holes to fix. Lots of questions still unanswered. But I feel like our process of going through and asking the right questions, finding the right answers, reflecting on our process, making sure we're good on other parts of life, has just led to awesome results. And I hope to continue to refine this process and expand on this process and put it to test more and see what great things we can come up with. So first year done. Hurrah! What a wonderful year. Just shout out to everyone that helped me. No, it was amazing. And I'm not going to continue the shout out. I'll see y'all soon. Thank you so much for watching if you actually did watch this.